finding the perimeter in a coordinate plane. We found perimeter a long, long time ago in your earlier math years. When you're asked to find the perimeter, what does that mean to do? When you directly say, find the perimeter of this figure, what do you do? Okay. What do we do when we find perimeter? Diego? Yeah, well, what did you say, finding or combining? Another try. Yeah, all you're doing is you're adding up all the sides. You're finding the sum of all the sides of the figure, the distance around the entire figure. Okay, so you add up all the sides. That's what that means. Add up all the sides of a figure. What is this? Find the perimeter of this. You know, hey, I have to add up all the sides of the figure. Okay, so if we take a look at this example, it says find the perimeter of the rectangle below. Well, we just said when you find the perimeter, you add up all the sides. So that's exactly what we're going to do here. So what are we adding together in this one? What would it look like when we set up our problem? Would you write down your paper or type up in your calculator? Erica? Good. Yeah, those are all the sides. You add these sides with those sides. And we get what? 25, what is it? 90. And we get 90, we label it as meters. 90 meters. And that is the perimeter, the distance around the outside of the figure. And to find the distance around the outside of the figure, you add up all the sides. Well, if we take a look at this example, okay, it says find, not distance, that should be perimeter, did not catch that. Find the perimeter of the rectangle graph below. Round your answer to the nearest 10 if necessary. What's a little bit different about this rectangle compared to the rectangle in example 1? One's in the coordinate plane. What did we have with the first rectangle? What were we given? Yeah, we were given the measurements, right? Were we given the measurements of this rectangle? No. But using what we talked about last week, what could we use? What little theorem can we use to find the distance of all those sides? Pythagorean theorem. Yeah, that's all you have to do. Okay, so we're going to take what we did last week with distance, and we're just going to find the distance of all the sides and then add them up. So remember, to find distance, you just make a right triangle. And it doesn't matter which side you find first. Let's find AD first. Okay? You make your right triangle, and you just plug those values in the Pythagorean theorem. The side you're trying to find is always your what? It's your C. Okay? So this guy, AD, is what we're trying to find. That's always going to be my C. Then it doesn't matter. I'm going to make this my A, and that one my B. And I'm going to label it down here. A squared plus B squared equals C squared. And then you just count to get your A and you count to get your B. Okay? Well, I count this side right here. It's 1, 2, 3, 4. So that's 4 squared. Plus, and I count here. My B is 1, 2. That's 2 squared. You can just type that all in one step in your calculator. You can break it down into steps. What do we get when we do 4 squared plus 2 squared? We know 4 squared is 16. 2 squared is 4. And what's 16 plus 4? 20. Right, say 20 equal to C squared. Do we leave it like this? No. What do we solve up to? Square root. So when we square root, this is what I'm going to ask of you when you find perimeter. You do not round the very, 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 very end. We rounded last week when we found distance because that's all we were doing. We found the distance of our line, we were done with the problem, we round. Okay? Whenever you're finding perimeter, do not round your answer to the very, very end. You have to keep your distance as a radical. So is 20 a perfect square? No. So just leave it. Leave it as radical 20. I know in algebra 1 you maybe simplified that. I don't care. We don't have to do that this year. Do not round. You're going to get the wrong answer if you do. Because it's going to adjust the rounding of the actual answer. You want the most precise answer as possible. Okay, so if you round each individual side, then when you combine them, it's not going to be as accurate. Okay? So just leave it as radical 20. Do not round to the very, 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 very end. And you repeat that process for the other sides. Okay? It might seem like a lot of work. You're like, oh my gosh, there's 4 sides. There's a little shortcut with rectangles. Okay? I'm going to find the next side. I'm going to find AB. So I make my right triangle. Again, the side across that you're trying to find is always your C. Doesn't matter, I'll make that my A, make that my B. Plug in Pythagorean theorem. So we count my A's 1, 2, 3, 4, 5, 6. We count here, our B is 1, 2, 3. We can plug that into our calculator. What do we get? 6 squared plus 3 squared. Okay? 45? 45. And again, do we leave it like that? What do we have to remember to do? Say that because we sometimes forget. Just want to make sure we're in line. Do we plug this in our calculator and round right now? No, we leave it. 45 is not a perfect square. Leave it as radical 45. Leave it as radical 45. Okay. Only round at the very, 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 very end. You're not going to get as accurate as me. So now let's find that next side. Let's find BC. Make our right triangle. Right, we're trying to find our C. Make that my A. Make that my B. What was it? BC is we're trying to find? Again, we're plugging those values into the Pythagorean theorem. When we count to get our A, I count 1, 2. When we count to get our B, I count 1, 2, 3, 4. What are you noticing right now? What do you notice? Yeah, we got the same exact values for BC that we did AD. So do we really need to do any work? Do we have to keep solving this? No, because what do we know our answer is going to be what? C is going to be radical. It's going to be radical 20. Sometimes that happens. So I do the same. So when you notice that, oh, these are the exact same numbers I got here. My answer is going to be the exact same. I don't have to do any more work. Okay? So I know BC is 20. A radical 20. Then we repeat the same process for CD. CD, trying to find this my C. Make my right triangle. And plugging into the Pythagorean theorem. And when we count, make this my A, that my B. 1, 2, 3. 1, 2, 3, 4, 5, 6. What are you noticing about your A and your B for this side as well? What do you notice? I got 3 squared plus 6 squared. What do you notice about that? Yeah, it's the same again. It's the same as this one right here, so we can stop. We already know what our answer is going to be. going to be radical 45 because it's the same exact legs as this one. So that kind of saves you some time. Okay. Well, now that we know the distance of all four sides, we are asked to find the perimeter. What are we going to do with all four of those sides? Yeah, just add them together. Okay. I'm going to do radical 20 plus radical 20 plus radical 45 plus radical 45. You have to be super careful, especially if you have a graphing calculator. I'm going to show you why you have to be really careful. Pull up mine on my smartboard. If you plug this in all in one step, okay, we're doing radical 20 plus radical 20 plus the two radical 45s. Okay, you're going to hit the second button and then the x squared button. That gives you your radical. So your radical 20. At this point, it's really, really, really important. You have to arrow out. So you have a graphing calculator. You're plugging this in. You have to remember to arrow out. Because if you don't, if you put the plus, then you're just adding all these radicals underneath the radical, and you're going to get the wrong answer. So you have to be very, very careful. Type in the first radical, arrow out, then put your plus sign. Some of you might have to close it with a parenthesis. If you have an older graphing calculator, arrow out. You might have to close it up with a parenthesis. It depends. So make sure you practice typing this in. And make sure your answer matches what I get to make sure you type it in correctly. Okay. This might seem really, really easy, but you need to make sure you're paying very, very close attention and practice plugging this into your calculator. They love to ask these type of questions on the OST that you'll be taking at the end of the year. They love to. They like to ask a lot of them every year. So it's really, really important you get used to typing this in, practicing, things like that. So when the test comes, you're pro. Okay? So this is one of those things they love to ask. Right? And it's not that bad, as long as you remember how to do it. Then hit enter. You should get this. If you not get this, let me know so I can combine see how you plug in correctly. The directions that are round to the nearest tenth, which again is how many decimal points? 1. So, you know, 22 point, you go to the first decimal place, it's just 3. Go to the number next to it, what's that 6 going to do to the 3? Gonna keep it the same, or is it going to bump it up? We will write as 22 point what? 4. Thank you. 22.4, because the 6 will bump the 3 up to make 4. 22.4. Technically, how we label it is units, because we're dealing with the coordinate grid. If you just wrote 22.4, I put that. They label things what you want in text. You don't have to worry about labeling. Like a blank won't put units on it. As long as you get the answer, I'm fine with that. That's why it's important to wait to round at the end. Because if you round each individual side, then you're kind of changing the answer for each side, and then you might change the final. One other shortcut for rectangles, if you're asked to find the perimeter of a rectangle, what did you notice about the opposite sides? They were what? So like AD, here's the side AD. The side opposite of AD, which is like right across from it, is BC. What do you notice about those distances? 3 equal, right? And what do you notice about DC? The side across from DC was AB. What do you know about those distances? They're what? They're equal as well. So that's a shortcut with rectangles. The opposite sides are the same. You notice in this rectangle as well. Sides and sides were the same. That is true for every single rectangle in this entire world. Okay? Opposite sides will always be the same with a rectangle. So that's another shortcut. If you're asked to find the perimeter of a rectangle, you really only have to find the length of two sides. And then it's going to be the same as the ones across it. So that saves you some time as well. If you don't remember that shortcut, not the end of the world. You'll just do a little more work. Questions over that? Go ahead, flip it over. It says find the perimeter of the triangle graph below. Round your answer to the nearest hundredth is necessary. Okay? Well, again, same exact thing. When we find the perimeter, what do we have to do with all the sides? Add them up. Okay? We weren't told what the lengths of the sides were, so we have to find them. Okay? I'm going to label, we'll find side 1 first. I'm going to say this guy is side 1. And this side's nice and flat. So do we need to do the Pythagorean theorem for this side if it's nice and flat? Now, Nicholas, what do we just do to find the length? Just count it. Good. Now, we got nice flat sides, so just count. Sometimes I see students trying to use the Pythagorean theorem. You don't need to do that. Just count it. So when we count 1, 2, 3, 4, that side is 4. Not a lot of work there. Have to count. The other side, though, they're slanted. So we have to use the Pythagorean theorem to find those sides. Okay? I'll find this one first. This will be my side 2. Make your right triangle. Label that C. The side you're trying to find is always your C. And make that my A, and make that my B. And you just plug it into the Pythagorean theorem. So when we count, my A is 1, 2, 3, 4, 5, 6, 7. Plus my B is 1, 2, 3. Again, I like to just do it once. To get really good at this, I just like to do it one step, save some time. So when we do this, 7 squared plus 3 squared is what? Oh, and 7 squared, 3 squared, calculator. Xavier, what'd you get?
I got right.
Well, you got, when you combine those, you got 58. Good. And then what did you do to get the radical? Square rooted it. Good. And just like we did on the front, do not round that. Leave it as radical 58. Only round at the very, very, very end of your graph. It's most accurate answer. And then you just have to do that for one more side. Side 3. Here's my green side, make my right triangle, make my A, make that my B. When we count to get our A, I get 1, 2, 3, 4, 5, 6, 7 squared. When we count to get my B, I only get 1. So it's 7 squared plus 1 squared. And what do we get when we do 7 squared plus 1 squared? Diego, what do we get? 8. And then what do we have to do? What is our very last step here? To get C by itself? What do we not want to forget to do? Square root. So C is radical 50. Then do not round to that very line. And then we are asked to find the perimeter. And again, when we find perimeter, what do we do with all of our sides? What? Okay. So our 3 sides that we got were 4, 58, and 50. So we're adding up those sides. We're going to do 4 plus radical 58 plus radical 50. And again, you have to be super careful when you plug this in your calculator. Make sure you arrow out. You have an older graphic calculator, close it with a parenthesis. And what do we get? I'll plug it in the calculator so you can talk about how to round it. Gives you 4 plus radical 58. Arrow out. Plus radical 50. And that's what you should get. If you do not get that, let me know. Check how you plugged in your calculator. Okay? It said round to the nearest hundredth in the directions. How many decimal places is the nearest hundredth? Decimal places is the nearest hundredth. Then we work ahead, look back. Going around incorrectly. Nearest hundredth is how many decimal places? 2. Right? So I know it's going to be 18.6. I go to my next one. That's an 8. Okay, the one next to the 8 is a 6. Is that going to keep it an 8 or bump it up? It's going to bump it up. Anything 5 or above bumps that number up. So our answer is 18.69. And then we say units. Again, not the end of the world if you don't label. Questions over that? Okay, got one more. Sometimes the figure is not graphed for you. You have to graph it yourself. So this is the hard part. No steps are different except you're graphing the figure. The biggest thing of why students miss this problem is because we don't plot our points correctly. So you have to be very, very, very careful at your points. Okay? When we plot, our first point is A at 1, 1. Plot that point. We have B is at 2, negative 1. We have C at 8, 1. And then we have D at 7, 3. And then label A, really important, B, C, and D. Really, really, really important. Label those points. That way you can find the distance of the right. And again, it says to find the perimeter of this rectangle around your answer to the nearest hundredth. So the steps are exactly the same. It doesn't matter which side do we want to find first. Does not matter which side do we want to find first. So Grace, which side do you want to find first? BC. Okay. Find BC first. Make your right triangle. Side we're trying to find is always our C. Make that my A, make that my B. Okay, plug it into the Pythagorean theorem. Count my A is only 1. Count to get my B is only 2. And what do we get when we do 1 squared plus 2 squared? We get 1 squared plus 2 squared. Gavin was 1 squared plus 2 squared. Good. What can we not forget to do at this step? Anthony, what do we still need to do at this step? How are we going to get C by itself? Good. Okay. So we get that DC is radical 5. What other side is also radical 5? Without having to do any work. What side is also going to be radical 5 without having to do any work? AB, the side across from it. Okay, so I'm going to say AB is also radical 5. That shortcut with rectangles, the sides across from each other are the same. If you forget, you just do a little bit more work, you're still going to get the right answer. But to save you some time, just know the sides across from each other are the same. And then it doesn't matter. We can find AD or BC. I'm just going to find AD next. Okay. And it's the same exact steps. Make our right triangle. my C. I'm trying to find. Count, that's 2. This goes 1, 2, 3, 4, 5, 6. Right, and then let's count. 1, 2, 1, 2, 3, 4. So then we get, where does it all? 1, 2, 1, 2, 3, 4, 5, 6. No, that's right. Okay. So we get 2 squared, plus 6 squared, and 4c squared. And what do we get when we do 2 squared plus 6 squared? We get 40. Again, don't forget, what do we need to do at this step? Frank, what do we still have left to do? Square root it. And again, don't round to the very end. We're just going to leave it as radical 40. Okay. Now we have our shortcut we can do. We know this side, AD, is radical 40. What other side's also going to be radical 40? Video? BC. Because again, the opposite sides in a rectangle are the same. That's only for rectangles. If you're told you have a rectangle, that works. Your practice, you might have a four-sided figure that's not a rectangle. That doesn't work. Okay? Only works when you have a rectangle. And then perimeter, we found the length of all our sides. And I kid you not, this happens. Students do a beautiful job at finding the distance of all the sides, and they forget to do the last step. What is the last step when we're trying to find perimeter? What do we have left to do? Okay. Add them up. Sorry to say. Have that add up all of our sides. Don't be that person that forgets. Okay? A lot of students who do this work, do all this work, do a beautiful job, and then they forget the very last step is by adding them together. Don't forget that step. So again, plug it in your calculator. Radical 5, arrow out, plus radical 5, arrow out, plus radical 40, plus radical 4. It said round to the nearest hundredth, so that would round to what? 17.1. That was our answer. Again, not the end of the world if you forget to label. Questions over that? I can show you individually. If you don't have a graphic calculator and you just have a scientific one, let me know. I can show you individually. I can't show you here. Other questions? Okay. The rest of the time is yours.